Hello and welcome to Pairs of Squares. See, it rhymes, you'll remember it. I made that up. It should help. Pairs of squares, when we have square roots of things and when we have two of them. That's what we're looking at. So, if we have the square root of 4, we know that's 2. Why? Because it's asking what times itself is 4, and we know that that's 2 times itself is 4. And we can break the square root of 4 into square root of 2 times square root of 2. And here we have a pair of squares. When we have a pair of squares, that makes square root of 2 squared. And we've talked about how squaring and square rooting are inverses and they cancel each other out. This makes a plane number 2. So when you see a pair of squares, it makes a plane number. Same thing with square root of 9. We know that's 3. Why? Square root of 3, because times square root of 3 equals, there's a pair of squares, plane 3. What about x squared? What times itself equals x squared? X. Because this means square root of x times square root of x. There's a pair of squares, which makes plane x. X to the 4th, well, we could go x squared and x squared. And there is a pair of squares. So again, it's like the square root of x squared times itself. And really the squaring and the square rooting cancel out. And we're left with this plane x squared. So a pair of squares makes a plane. Let's look at the problem like the number 25. We've done factor trees in the past. You know how to break this down. 25 breaks down to be 5 and 5. That's as far as it goes. Let's put radicals on the ends. And here we have a pair of squares. Square root of 5 times square root of 5 equals plane 5. So this answer is plane 5. Now it gets a little more tricky with something like 20. We can start to break this down and say, okay, here is 4 and 5. And 5 can't go anymore, but 4 can keep going to be 2 and 2. Let's put square roots on the last ones. So this really is square root of 2 times square root of 2 times square root of 5. Is there a pair of squares? Why, yes, there is. There's a pair of squares here, which makes a pair of squares here. So this pair of square roots of 2 make a plane 2 times, this is just left over, there's no partner for him, he's left out in the cold, he's got nobody to dance with. He's square root of 5. These guys are friends, hey great, we get to be playing 2, and where's my other friend? Oh, no friend for you. Square root of 5. Now, you can also think about this sometimes by thinking, how can I break 20 down into finding a perfect square? A perfect square is a number that you can take the square root of easily, like 4, 9, 16, 25, 36. Well, I know 4 is a perfect square, so if I thought about it, I could say, hey, that's the same as 4 times 5, and I know 4 is a perfect square that makes plane 2. This is another way you could think about it and get the same answer. But some people can't think of those perfect squares, so this is another way that works. Okay, how about 18? We could go 18 would be 6 and 3. And 6 can go to be 2 and 3. These can't go any farther. This can't go any farther. I'm going to put radical symbols on my last ones. Is there a pair of squares? I see 2 3s. They can be friends and make a plane 3. Is there one out in the cold? Oh, sorry, 2. No friends for you. 3 times radical 2. Again, you could think, what perfect square divides into 18? Is there a perfect square that I know? Let's see, 4, 9. 9! 9 is good. So I could do 9 times 2. That's the same as 18. And I know that 9 is 3. Square root of 9 is 3. So I could get my answer that way too. Oh, look. Same thing. 72. Here we go. How about 8 and 9, 3 and 3, 4 and 2, 2 and 2. I'm finished. Let's put radicals on all my last ones. So the square root of 72 is equal to square root of 2 times square root of 2 times square root of 2 times square root of 3 times square root of 3. Are there any pairs of squares? 2's are pairs, that makes a plane 2. 3's are pairs, that makes a plane 3. One guy left over here, so I just put my planes together and put my radicals together. I only have 2 planes here, so it's 6 radical 2. 108. I can't think of what goes into 108. Nobody really can very good. We're not that smart. But we know it's even. And when it's even, we can always try 2. That's a 5 and then a 4. 54, I think that's also even. I can do 2 and 27. Oh, I know 27 is 9 and 3. And 3 and 3. There's my bottoms. Square root, square root, square root, square root, square root. Is there a pair of squares? Here's a pair of squares. We're friends. Okay, that makes plane 2. Here's a pair of squares. We're friends. Okay, that makes a plane 3. Any friend for you? Sorry, you're outside in the radical. So this is 6 times the square root of 3. Very similar to the last one. Okay, I'm hoping this is making sense to you now. Let's look at what if we have something like this. If we have x to the, or square root of x to the 3rd. Are there a pair of squares in here? Remember, this means x, x, x. Is there a pair of squares there? Yeah, these are a pair. So this makes a plane x with 1 left over. That's one way to think of it. Also, I could think, well, is there a perfect square like x squared? This is the same as x squared x. And I know that is just plane x. So that's another way I could think of it. Also, I could think, the 2 in here would make 1 whole pair with 1 left over. If it's x to the 9th, remember there's always a little 2 up here. If there's nothing written, it's always a 2. So I'm thinking, are there pairs? I could make 2 of them, and 2 of them, and 2 of them, and 2 of them, and have 1 left over. So that gives me 4 pairs of squares, which would be x to the 4th, with 1 x left. Or I could think, well, wait a second. I know that this could be x to the 8th with 1 left, and I know this is x to the 4th, plain x to the 4th, with 1 left over. What also happens here a lot is that if you see these numbers, we can divide. 9 divided by 2, you remember when you were learning how to do this kind of a thing when you were little kids? 2 goes into 9 4 whole times. 2 goes into 1 none, but there's a remainder of 1. So hey, it goes in 4 whole times. So we've got x to the 4th with 1 left over out in the cold. He's under the radical. So what if we had square root of, let's do it over here, x to the 21st? Well, 2 goes into 21 10 whole times, so I know there's going to be 10 pairs of squares with 1 extra little guy. Sorry, friend. You can't be with the plain numbers. All right, and then the last thing, let's connect this to what we know about fractional exponents. X to the 3 over 2 power, you should know now, means square root of x to the 3rd, which now you should know that means this is a squared with 1 left over. That means there is 1 plain x with 1 left over. So if the directions are to simplify this using a radical, your final answer should look like that. That's the simplified version. Last problem, what about x to the 15 over 2 power? At this point, you should know. Actually, go ahead and pause it, try it. And now start the video and I'll show you. This means the square root of x to the 15th. And if we divide, that means it is x to the 7th with 1 left over. And the 1 left over goes in the radical. I'm hoping you could get this problem right to equal that. If so, you are in good shape. I hope you enjoyed. Pair of squares just made you smarter. See ya.